Okay, so just look at a couple of bits on the transformations of the sine curve and cosine curve. So let's have a look what the question is talking about. So it says that the graph of that is shown. So we've got the graph of that, and it's telling us 91. So it's telling us that that is 91. So it's giving us a hint there. Okay. So that's the information for the sine curve. So we know this is the sine of x. If it was the cosine, then we'll remember the smelly nose. So 1, 90, 180, 270, and 360. So we've got to remember the cosine curve is the sine curve just translated 90 degrees. So let's have a look. What's the question actually want? So we've got on both grids, sketch the graph of the transform functions. So this first one says we've got to do the sine of x minus 45. Well, what we've got to remember is the rule says that if we've got a function and we change it into something plus, then that is a translation through vector negative a, 0. So it's a translation of negative a, 0. Well, they're telling us the a value is negative 45. We just take away 45. So negative 45 is plus 45 degrees. So move 45 degrees to the right. Okay, so that means we take all the key points and move them 45 degrees. Well, if we notice the scale of the graph, so the scale of this graph is quite nice. It's looking at working every 45 degrees. So if we take this point here, then it's moved to there. And if we take this point here, and it's moved 45 degrees over, so it's there. And we take the 180 degrees point, it's moved to there. And if we take the 270 point, that was there, it's moved to there. And if we take the 360 point, then it's moved to there. So that means that our curve is going okay. So the curve's doing that, and again we should recognise that this curve would continue, and therefore it's going to continue down, and one's going to be over there. Negative one's going to be over there. Okay, so that's that one translated over. It then asks us to work with the next function, which is y equals 2 sine of x. And because we should recognise that this is a transformation of f of ax, because, sorry, not f of ax, it's 2 f of x, so it's a f of x. So we've done something to timesing by the function. We started with the original function sine x, we've multiplied by 2. So this tells us that we multiply all the y coordinates by 2. Okay, so we take the original graph and all the y coordinates are going to be multiplied by 2. So the original graph underneath might help us see what's going on. So the 0 point doubled will still be 0. The coordinate 91 will now become 92. The 180 coordinate was 0, so the y value was 0, so that's going to stay as 0. The negative 1 values, well, at 270 on the original curve it was at negative 1, so at 270 on this curve it's now going to be negative 2. The 360 value on the original curve was 0, so that's going to stay as 0. So basically what we've got to show with this is that the curve has gone to now an amplitude of 2 down to negative 2. Okay, so that's the important thing about this one. So that's just a quick example of transforming the sine curve using a couple of function changes, and just remembering the rules of transformations of functions. So when the function is changed by a scalar outside the function, then you multiply all the y coordinates by that scalar. So in this case, you multiplied all the y coordinates by 2. Okay. Again, must remember to read the questions really carefully. It did say write down the coordinates of P. So what has happened to P? Well, P in this case had gone to 135, 1. And on the other function change, the P value had changed to, because the coordinate of P was there, and the P value had changed to 92. So again, it's just a case of make sure, guys, that we read the questions and always answer what they want. So we've drawn the curve, but we must make sure we put down the coordinate P as it was asked for.